Hi everyone, so in this video we're going to be talking about correlation and regression in the next video that's going to be with this one. So first off, a correlation is a relationship between two variables. The data can be represented by the ordered pairs x and y, where x is the independent or explanatory variable and y is the dependent or response variable. So this sounds complicated. We've already seen this before. Essentially, it means that you can throw the data onto a scatter plot and get a whole bunch of points of the data. So for example, one, that's exactly what we have. We have a scatter plot, and the idea of correlation is that you can kind of see that these are trending upwards, right? So consider the scatter plot, which shows the weights in carats and retail prices of 23 diamonds. The dots clearly show an upward trend. Again, just because they happen to be going upwards if you look at it from left to right. Larger diamonds generally do cost more. Because the prices tend to increase as the weights increase, this is a positive correlation, as both variables tend to increase or decrease together. Right? In example 2, we see something that's the opposite. Right? So in this one, it is a scatter plot of variable life expectancy and infant mortality in 16 countries and shows a clear trend. But this time, if you look from left to right, they seem to be going downwards. So as life expectancy goes up, the infant mortality goes down, right? So this time, we call that a negative correlation. Because the variables are going in opposite directions. As life expectancy goes up, infant mortality goes down. Right? Again, which makes sense because countries with higher life expectancy tend to have lower infant mortality. All right. With that said, what we're going to look at is we're going to look at how to create this scatter plot and go into a little bit more detail on specifically how much of a correlation is there. So for that, we're going to need to talk about the strength of a correlation. Right? So for these two different scatter plots, you can see a little bit of a difference. So in the first one, again, if we kind of just try to roughly draw the line that kind of gets closest to the direction those dots are going, you can see that the dots are all really packed around that line. Whereas the one on the right, again, if we try to do vaguely the same thing, you can see that the dots are much, much more spread out. All right? So in this case, on the left, we would tend to say that that has a strong correlation. And on the right, if they're spread out like that, we tend to say that's a weak correlation. All right. Now again, so far this has just been me kind of vaguely drawing some lines through the dots. So we're going to get Excel's help here to get us a little more precise. So there's something called the correlation coefficient. And it's usually denoted by a small r, and it's actually a measure of the strength of a correlation. Right? So we're going to jump into example 1, and I'll explain what everything means along the way. For example 1, the table below shows the temperature in degrees Celsius and the total amount of ice cream sales from a stand over 12 days. Find the correlation coefficient and interpret it. Then determine if the correlation is significant at alpha equals 0.01. We'll talk about that part last, but for now, let's head over to Excel, get all of this information in there, and we'll start figuring out how to get that correlation coefficient as well as a scatter plot to be able to visualize it a little bit better. Okay, so here we are in Excel. We already have the temperatures in degrees Celsius and the ice cream sales in dollars put into Excel for us. So the first thing we're going to do is make a scatter plot of this, that way we can visualize it a little bit better. So what we're going to do is we're going to select all of our data. We're going to go up to Insert, and under Charts, there should be one that says Insert Scatter or Bubble Chart. If you don't see it, just go ahead and click that recommended charts. You'll see a bigger list that you should see it on the left. But for us, it is right here, so we can go ahead and click that. And we would just want the basic scatter plot, so we're going to pick that very first one. We don't need anything fancier than that. So Excel made the scatter plot for us. So that part is completely done. And as you can see, just from this, we should be expecting a positive correlation. And it does actually look like they're fairly tight, but it's also a pretty small set of data. So instead of trying to guess about how strong it is, that's where the correlation coefficient is going to come in. Okay, so up here, I already have a spot for us to do it, and I have the formula right underneath it. So for the correlation coefficient, it is equals CORREL, and as always, Excel will try to autofill it for you. Then the next up, you are going to put your entire set of X values, comma, your entire set of Y values. Hit enter, and Excel does the correlation coefficient for you. All right? Now, how to interpret it? So first off, if the data was going down, we said that was a negative correlation. That would actually be reflected in the correlation coefficient. It would actually be negative. So first off, we can see that it's positive, so we do know it's a positive correlation, which we expected because it was going up, right? Next up, to see if it is strong, weak, or if there's just no correlation at all. For that, we just look at how close to 1 or 0 it is. So if it is really close to 0, between 0 to 0.1, then we say that there is no correlation. More or less, the dots are fairly random at that point. For 0.1 to 0.5, we would say that that is a weak correlation, right? Or, like in our case, if it is 0.5 or above, in our case it is 0.9575, so that's really, really close to 1, we would say that this is a strong positive correlation. Which again, makes sense because they're pretty tightly packed right there. Okay? That's the first part. The second part was determine if the correlation is significant at alpha equals 0.01. Okay, so for this part, we are going to need a table. And to look up something on that table, we're going to need to just know how many points of data we have. In this case, in the problem, it even told us right away. It did say that it was over 12 days, but you could just count up how many points there are. But in this case, it told us there are 12. So just so we don't forget that, I'm going to go ahead and throw on here n equals 12. And it also says that our alpha is 0.01. Okay, so we're going to need to look something up on a table at this point. Right? So that table is going to be this. It's called the Pearson Correlation Critical Values Table, and in my math lab, you will have a link to get to this table. This is the one time that Excel's not going to do something for you. You actually are going to look something up on the table. So what we're going to do is we're going to look up our n, and we're going to look at the alpha equals 0.01 because that's what we were given in our problem. So our n was, oh, that is not drawing. Our n was 12. And then again, our alpha was the 0.01. So the value that we actually want on this table is 0.078. Okay, so we're going to go back over, and that's called our critical value. So we're going to go back over to the problem. So our critical value was 708. Okay, so here's what we do with that. The last thing we want to know, again, based on the question, is we want to determine if the correlation is significant at this alpha. For it to be significant, the absolute value of R needs to be greater than or equal to the critical value. That means it is significant. If it's less, that means there is not enough evidence to say it's significant. Okay, so since we know that now, our correlation coefficient was 0.958 if we round it to 3. So we have 0.958. Is that greater than 0.708? Yeah. That's essentially, you have about 96 pennies versus 71 pennies. So yeah, that is in fact greater. So in our case, we are going to say, if I just erase this real quick so we can put our conclusion. We're going to say there is sufficient evidence at the 1% level of significance, and remember that 1% just comes from alpha equals 0.01. 0.01 is 1%. To conclude, that there is a significant linear correlation. And then we are done with that first problem. So with that, let's go ahead and look at the second example. So for this one, 22 random people got $1,000 to spend at a casino. They all spent different amounts of time at the casino. This is how much money they had left. Find the correlation coefficient and interpret it. Determine if the correlation is significant at alpha equals 0.01. So again, we're going to be doing the same thing. We just have a different data set this time. So I will go ahead and scroll through just so you can see all of these. And we're going to take all of those to Excel. So here we are in Excel. Again, we have all of our data put right here. And first thing, again, we're going to do is we're going to go ahead and make that scatter plot. So I know you can't see all of my data currently, but just select all of the data. Once you have it selected, make sure you are on Insert, select the scatter plot, and again, we're just going to pick the very first one. This is what our scatter plot looks like. Again, if you notice, this time you can clearly see it trending downwards. As it is going left to right, you can see that it is going down. So we would expect this to be a negative correlation since it is going downwards from left to right. These dots also appear to be more spread out than the other ones. So we would assume that it's going to be a little weaker as well. Right? That said, we are going to go up and do the correlation coefficient next. So again, remember this is just equals CORREL. Then you put in your x values. Sorry. Put in your x values, then make sure to actually hit the comma, and then put in your y values, and then you can hit enter, and it gives us r equals negative 0.82019. All right, so again, right off the bat, we immediately see that this is negative. So it is for sure a negative correlation. And even though it is a little weaker than the other one, this is also between 0.5 and 1, well, specifically between negative 0.5 and negative 1. So we would also say that this is a strong negative correlation. All right, again, we're going to go on to the second part of the problem that says determine if the correlation is significant at alpha equals 0.01. So this time there was 22 different points of data. So whenever we go this time onto the table, we are going to be looking at 22. And again, we want alpha of 0.01. So specifically the 0.537. That is going to be our critical value. So 0.537. All right. So remember, at this point, all we need to do is we are going to check the absolute value of our correlation coefficient, and we're going to see if it's greater than or less than our critical value, so 0.537. So in this case, the absolute value of our correlation coefficient, you just take off the negative, it's 0.820 if we round it to 3. We're comparing that to 0.537, which is our critical value. Again, in this case, that is greater. So since it is greater, we again are going to say that there is enough evidence at the 1% level of significance to conclude that there is a significant linear correlation. And that is the second example. So again, just to reiterate, the basics is to make a scatter plot, highlight all of the data, go to insert, insert a scatter plot. For the correlation coefficient, is just equals CORREL, put in the first set of data, so the X values, put in the second, which is the Y values, and then it will give you the correlation coefficient. Compare that to whatever critical value that you find on the table based on both how many people or how many samples you have. Sorry for my dog. And then, so we're going to get the, as I was saying, the number of samples that we have and whatever alpha is given to you in the problem, and that will give you your critical value on the table. Compare the absolute value of the correlation coefficient to that, and it will tell you if there is enough evidence to conclude that there is a linear correlation. All right, that is all for correlation. In the next video, we're going to be talking about regression. So in the very beginning of this, I kept trying to draw a line approximately through the dots to see around where they would be going. The next video, regression, is going to be talking about how to get that exact line that best fits all of those points. So I will see you in that video for part 2 of these notes.